Okay, so the next few are a little bit easier. Here we are in number 4. There are a couple of different ways to look at this, finding the derivative of the square root of 9x. You could look at it as an inside function, 9x, and an outside function, the square root of u, and use the chain rule. But the easier way is to actually just factor out the 9, take the 9 out of the square root. That gives you 3 times square root of x, or 3 times x to the negative x to the 1/2. And then you can go about it, different ways. You can either say, well, I already know the derivative of the square root of x is 1 over 2 square root of x, and then the 3 is a constant multiple rule, so that just goes in front of that, times, and that gives you then 3 over 2 square root of x. And now let's see which one that is. And that will be this one here, a. Okay, so that one's a. Now, 5, find the slope of the normal line. Now, this one's the normal line to the curve y equals 4x squared minus 5x at the point 1, negative 1. So we're using the same formula again that we had in number 1, the one from 2.6. So y minus the y coordinate of the point equals negative 1 over f prime of the point, the x coordinate of the point, so that's f prime of 1, times x minus the x coordinate of the point. So that would be it. So the only thing that we're missing here is f prime of 1. So what is f prime? F prime would be 2 down, so that's 8x minus 5. F prime of x is 8x minus 5. So f prime of 1 is 8 times 1, that's 8, minus 5, that's 3. So the slope of this line here is negative 1 over 3. So it's negative 1/3. So that's E. This would be the solution. Okay. Moving right along, let me move this guy down here to 6, 7, 8, and 9. Let's see if we can knock them all out in this video. And here we go. Find the y-intercept of the tangent line to the curve y equals x cubed at the point 1.1. So that's basically, you have to use the tangent line formula, the same one that we've been using before. Y equals the y minus the y coordinate of the point equals y prime of the point 1 times x minus the x coordinate of the point. Okay, and then you have to shuffle it around and put it into the slope-intercept formula format, and then see what number the intercept is. Intercept of the tangent line. Okay, so we're at the right thing here. So let's find y prime of 1. Y prime of x, or f prime of x, equals 3x squared. So at the point with the x coordinate 1, 3x squared would be 3 times 1, that's 3. So 3 is the slope. So now we can fill everything in here. Y minus 1 equals 3, that's the slope at that point, times x minus 1. Then we solve it, so that's 3x minus 3. Y minus 1 equals 3x minus 3 minus 3. And that means y equals 3x minus 2, right? Plus 1 on both sides here will give you minus 2 over here. So this one here is the y-intercept. And which one is it? Oops. There we have a problem. We overlooked this part here. There you go. So let's go again. Let's redo this. See, that's the advantage of having a multiple choice. The negative 2 didn't work out here. So, but I overlooked the second part of the function. So the y prime or f prime of 1 No, wait a minute, we're over here, and there is a -2. Sorry, I skipped problems. All right. Okay, so the -2 that we had was fine, so it is G for 6. Fine, so let's move on to 7. At how many different values of x does the curve x to the 3 minus 2x have a tangent line parallel to the line y equals x? So what do we need to figure here? The slope to the curve of this graph here of the function has to be what? 1, right? Because the line y equals x has a slope of 1. So the tangent line parallel to this line has a slope of 1. So the question is really how many points on this graph have a tangent line with a slope of 1? Or in other words, the f prime of this function here equals 1 at how many points? Okay, well, so f prime of this one is what? Prime of x. This terrible handwriting because I'm just doing this with the mouse here. So it's 3x squared minus 2. And now the question is, at how many points is this? Does this equal 1? 3x squared minus 2. And so then you have to reformat that into 3x squared minus 3 equals 0. And now you just have to find the solution. How many solutions are there to this equation? And the answer to that is going to be 2. But you just have to go through the steps here of either you can well, actually the easiest way is to just do it this way. 3 plus 3, right? Plus 3 equals 3x squared. So that means 1 equals x squared. That means x equals a plus or minus the square root of 1. And that means x equals 1 or -1, and that is 2 solutions. That means there are 2 tangent lines. One is at x equals 1, the other is at x equals -1, and both of these tangent lines have a slope of 1, and that means there are 2 tangent lines to this curve here that are parallel to the line y equals x. So the solution is 2 over here. Okay, let's get rid of that. Now let's move on to 8. Find the derivative of e to the x times x squared plus 2. Now in this case we have to use the product rule because there are 2 functions here, right? It's a product of 2 functions. One of the functions is e to the x, the other function is x squared plus 2. The product rule is the prime of this whole thing here is the prime of the first factor times the second factor plus the first factor times the prime of the second factor. Okay, so let's do it. It's going to be f prime is going to be the prime of e to the x is e to the x times the second factor, that stays what it is, and then plus the first factor, which is e to the x, this is not the prime, this is the actual first factor, times the prime of the second factor, which is 2x, right? So 2x, okay? So this is our prime. Now we just have to see what did they do here to put that into this format. Looks like we want to factor out e to the x out of both of these terms, right? Here is one e to the x factor in here, and here's an e to the x factor. So let's factor it out of both terms. We get e to the x times x squared plus 2 plus 2x. And from there, it's a very short step to this right here. So F is the correct answer on this one. Okay. Let's see, we're looking at 9. Find the second prime at the point where x equals 0 of this function right here. Again, this is a case for the product rule. One of the factors is x squared, the other factor is e to the x. So the prime of this one is prime of the first factor, 2x, times the second factor, plus the first factor times the prime of the second factor, which is e to the x. And let's factor out e to the x again. E to the x times 2x plus, plus x squared. And now the question is, what is, oh, this is the, I'm sorry, this is the first, this is the first derivative. We're looking for the second derivative. So in this case, I would actually not do this simplification, because if you're taking the prime of this thing here, you're just looking at having to apply the product rule twice, whereas if you transform it into this thing, you're looking at having to apply the chain rule. Well, whatever you're more comfortable with, it should give you the same result. It doesn't matter. So let's put the second prime in here, and let's do the prime of the first factor, or this one, is 2, right? 2x is the first factor, the prime of that is 2, times e to the x, that's the second factor, plus, we're still looking at the first term here, plus the first factor times the prime of the second factor. The prime of the second factor is e to the x. So now we're done with the first term. Now plus, same thing again, product rule again for this one. Prime of this one, now this is, if you notice, this is the same as the original function, right? This is x squared times e to the x. X squared times e to the x. So we can just do this thing all over again. So it's e, what the x? No, it's 2x times e to the x plus x squared times e to the x. So I don't, at this point, I don't have to necessarily simplify that. I can just, if you're comfortable with that, just plug in 0 for everything, for all the x's. So what is this? E to the 0 is 1. 1 times 2 is 2. So this here is 2. Oh, we're running out of space here. So equals 2 plus 2 times 0 times this. This is going to be 0. This is going to be 0. Plus 2 times 0. This is also going to be 0. Plus x squared, this is also going to be 0, this is also going to be 0. Okay, so you have a bunch of zeros here and a 2. So 2 right here, this is your answer. All right, moving right along here. Now, what's going on with this guy?
Which guy?
10. Find the value of this limit right here. Now, this limit should look to you familiar to what we've done in class and in homework assignments in the past. Basically, to find the limit of this, you should try to reduce this form to something that doesn't have 0 in the bottom and or parses into things of this format, because we know what the derivative is of this guy here. Let's write it down here. Sine x, sine x over x. We know that that equals 1. The limit as I should not just write 1 there, I should write the limit as x approaches 0 of this thing here equals 1. We know that. So as long as we can reduce this thing to something of that nature, then we're going to be in good shape. So I'm just going to make a little shortcut here because I'm having a hard time writing with this thing. This here is my shortcut for limit as x approaches 0, okay? So, but don't just leave it out completely, okay? So now, we want to make this here into sine square of x, okay? So in order to accomplish that, we have to multiply the numerator and the denominator by the conjugate of cosine x minus 1, which is cosine x plus 1. That will give us cosine square x minus 1 over 2x times cosine x plus 1. Okay? Okay, so, and now we substitute this stuff up here. That was our whole idea. We substitute this by the Pythagorean identity with sine square of x. But actually it's reversed, right? So we need to have 1 minus cosine x. So we need to move a negative sign in front of this, okay? So we're substituting this thing up here by negative sine square of x. So the next line is going to be limit, and again, this is my shortcut for limit as x approaches 0. And now we have negative down here. We have sine squared of x, and I'm now going to do 2 steps in one. Okay, I'm going to split this up into 2 factors of sine x for the numerator, and the 2 factors on the bottom I'm going to use as the 2 factors of these guys here. Okay, so 2x is going to be down here. That's this factor, and cosine x plus 1 is down here. Now, right, okay, so now this is an equal sign. No, this is a negative sign. This is not an equal sign, this is a negative sign. Okay, how do I get rid of that? Undo. Is there an undo thing? Let me see. Yes, there is. Haha. Very good. Okay, so limit of negative, here's the equal sign. Limit of, as x approaches 0, of negative these 2 factors here. Okay, good. So now this here parses into negative 1/2 times sine x over x. Sine x over x, the limit as that approaches, as x approaches 0 of that is 1. So that is 1 times 1 times 1. This is a times sign, is a dot. Okay, times, so here's a big equal. Now I'm solving the limit, right? So now sine of 0 is 0. And luckily this denominator here is not 0. So I have a valid expression here, even though the numerator goes to 0, right? Because cosine of 0 is 1. And then 1 plus 1 is 2. So 0 over 2, this factor here is 0. But that makes this whole entire expression 0. So the solution, and that's it. So it's not times 0. And so this thing is 0, and that is my solution right here. Okay, let's get rid of that. And let's look at the next one. Now, this one here is a function that requires the chain rule because it has an outside function, which is, outside function is u squared, and the inside function, so y equals u squared, and the inside function is u equals sine of x. Okay, so now I work my way from the outside to the inside when I take the derivatives. So the derivative of this whole thing, what is it? F prime of x equals 2u, and for u I substitute sine of x, so 2u is 2 sine of x. That's the derivative of the outside. Now I have to add the factor of the derivative of the inside, which is the derivative of cosine, the derivative of sine x, and that is cosine x. So this here is it. I don't need these parentheses. So G is my correct answer for this guy. All right, now we're done with the multiple choice problems. Let's get rid of this. Let's do one more in this video and then see if we need to move on to the next one. So 12. Find the slope of the tangent line to the curve y equals x minus 1 over x at 1, 0, at the point 1, 0. So using definition 1 from section 2.6 or definition 2 from 2.6. The definitions of the derivative, we had them on the board. The one of them is limit as x approaches a of f of x minus f of a over x minus a. And then the other one is limit as h approaches 0, or delta x approaches 0, of f of a plus h minus f of a over h. Okay. Now, you can, the real question here is use either definition for Roman 1, Roman 2, and you would just plug this in. Let's just do it with the first one. Okay, so if I have limit as x approaches a. Now, what is a in this case? A is the x-coordinate of the point, so it's 1. So as x approaches 1, now I need f of x over here, so that would be f of x is x minus 1 over x. and then minus f of a. So let's just plug a into this here to find f of a right quick, or we don't even need to do that because they give us a point. So we know that this here is f of a. So 0 is f of a. And then in the numerator we have x minus a, x, and a is 1. So there. Okay, so this we don't even need. So the limit then is x minus 1 over x minus 1. So then I would in this case, suggest you find, well, it's really just algebra now from here, but I'm going to go through it right quick. So you have to make this a common denominator. Common denominator is going to be x, right? So you have to multiply x by x over x, so that's going to be x squared minus 1, we don't have to do anything to the second term here, over x over x minus 1, and I can pencil in here minus over 1. Now I cross multiply, so that's going to be equal to, I should use my shortcut again, but I'm going to write it out here. X, as x approaches 1, of, what is this? X squared minus 1 times 1, right? This thing comes up here, so this is just 1. And then times x, over x times x minus 1. There. Okay? So this here factors into x minus 1 times x plus 1. So one of these factors is going to be reduced by this factor in the denominator. So I'm going to be left with x plus 1 because the x minus 1 factors reduces with this one. X plus 1 over x. X goes to 1, so this is going to be 1 plus 1 over 1, and that is 2. Okay, so let's see. That is the slope of the tangent line to the curve y at y equals x minus 1 over x at 1, 0. This is the slope by the first method here. Okay, and then using your results from part A, find an equation of the tangent line at 1, 0, right? So just remember the slope of 2 as we erase this whole thing. Now we're going to use the 2.6 formula again of the tangent line, which is y minus the, so let's see, it's y minus the f of a, which is 0, equals the slope of the tangent line, which we just figured out is 2, times x minus the x coordinate of the point, which is 1. Okay, solve it. Y equals 2x minus 2. And that would be the answer to B. 2x minus 2. Done. All right, now this one here, this is an interesting one, right? Let me move it down a little bit. Let's first erase our stuff there. I think we can squeeze one more in here. Okay, 13. This one is interesting. I have a hard time thinking that this is difficult, but I don't want to scold you. Okay, so we're just going to see, what is the slope? What is f prime of negative 4? Well, it's the slope of this line here, of the tangent line to the curve right here. Let me use a different color. I don't like this color. Yeah, it's red. What happened? So that is this slope. That's about this one. Now the next one, at f equals negative 3, I would say that's right around here. It's pretty close to 0, maybe slightly up. That is f prime of negative 3. F prime of negative 1 is right here. That's about that. F prime of 0 is right around 0, maybe slightly up. F prime of 1 goes down, like about this way. F prime of 2 goes down, but not that much. And f prime of 4 goes up a lot, right? So let's see. If we have to put them in order, it looks like this one here is the steepest slope, right? I'm just going to end this here on this side. I'm just going to write the numbers here so I don't have so much writing to do. So what is the next steepest slope? Looks like to me this one here, huh? Okay, so that was what? At -1, so -1 is over here. Then what's the next steepest slope? Well, maybe this one or that one, right? It seems like probably they're pretty darn close to equal. So no, I think this one here is actually a little bit steeper than I had drawn. So I would go for this one with that one. So that's -3. And then the next one is that other one that we had set our eyes on here, this one at 0. And now we're getting into negative slopes, right? So now which one is the least negative slope, the least steep negative slope? I think it's this one. And then the next one looks like this one right here, right, at 1. And then the next one is this one way over here. That's at -4. There. Aye, aye. Bad handwriting with the mouse. You try it. Okay, so that's the answer for this one.